All right, just to wrap up these derivatives, I said a couple of examples and then I just gave one example, so I just want to give two more examples. So one is another function would be a function of a tensor field, but it's a scalar value function, and that would be the invariance of a tensor. For example, the first invariant of the tensor A. Remember that I1 means the trace of A, which is also in index notation is the sum of the diagonal components once you have a basis. So this is in components. So now my function of the tensor A is the trace of A, and I want the derivative of this function with respect to A. So that just means the partial derivative of I with respect to I j k. Again, note that this part right here, that's still independent of basis, whereas the second part right here, that one is in the component. So once you have chosen a basis, and that will be the partial of the AII with respect to AJK. Notice that this was a scalar valued function, and this is a second order tensor. So this is a second order tensor. Because now we have these two free indices, j and k. The I is not a free index because there's a sum over I implied here. Sum over I implied. So it is a second order tensor, there's two free indices. So what is this derivative? If you remember, so you have the derivative of the first invariant with respect to the tensor A, which is this in components. It's not exactly the same, so in components this is derivative I with respect to jk. If you see what I did before for the tensor A with respect to the tensor A, this will be this only one when I equals j and I equals k, right? So this will be I equals j and I equals k, and then I can use the Kronecker delta to get rid of either I make, I equals k, so I put k here, or the other way around, it doesn't matter, right? So I can also get rid of the I right here and substitute that with a j. So that would be delta jk. So in other words, if I take the derivative of the first invariant with respect to a tensor, then I'm gonna get a second order tensor, with components delta jk, and this is the identity. So the derivative of the first invariant with respect to the tensor is the identity tensor. So this is actually something that is very, very useful. And then there's other derivatives, for example, the derivative of the second invariant of a tensor with respect to the tensor, and that would be the first invariant times the identity minus the tensor itself. And then the derivative of the third invariant with respect to the tensor A, and that would be the third invariant, which is the determinant, times A inverse. So these are some